everybody. I'm Joshua Miner, and I'd like to welcome you all to the OpenTimelineIO segment of the Academy Software Foundation's Open Source Days for 2020. And today we're going to talk about OpenTimelineIO. First, I'm going to give you an overview, sort of status update. What is OTIO, and what have we been up to for the past year or so? We have a couple of co-presenters from the community talking about use cases and how they're using OTIO in practice. We do a little bit of roadmap, and then there'll be a good segment for live questions and answers at the end. So first, let's start with just an overview of what is OpenTimelineIO in case you're wondering. So OpenTimelineIO is it's an open source project. It has three sort of main important parts. The first is it's a file format for storing editorial timelines. There's also an API for software engineers to use when building applications and workflows that use timelines. And it's also a set of adapter plugins for converting between OpenTimelineIO and other timeline formats. So just to sort of talk about in general, like an editorial timeline can be quite complex, kind of lots of tracks, thousands of clips, and it can really kind of capture years of creative filmmaking decisions. So this image here is about 20 minutes of running time of Toy Story 4. And you can see there's a whole boatload of audio tracks and video tracks and lots of stuff going on in there. So OpenTimelineIO tries to capture this. The file format and the API for OTIO have a unified data model that has concepts like tracks and clips, transitions like cross dissolves, markers, things like that. So most of the things that you would see in an audio or video editing application can be represented in OTIO. However, OTIO doesn't actually deal with the actual like video or audio media itself. Instead, we use a media reference to point to where that audio or video is in a file or URL or wherever you want. So OTIO is dealing with the structure of everything and sort of pointers to the media. So OpenTimelineIO can hold all that timeline information in a file. And then with adapters, we can convert to and from lots of other formats. And since the adapters are plugins, the system can be extended to support various common file formats in the industry, as well as formats that might be special to your workflow. And so by converting to and from those different formats, it allows us to interoperate with lots of applications. So we can interoperate in some form with all of these ones here. And we also strongly encourage developers to add native OTIO support to their applications. We'll talk about that a little bit later as well. So whether your application is as a third-party like commercial product, or whether it's an in-house tool, you can use, software engineers can use the OpenTimelineIO API to directly read and write OTIO files, as well as to manipulate those data structures in memory. And so by doing so, your application will gain the ability to work with this growing set of adapters, and gives your application the flexibility to read and write all these different file formats. OTIO also includes a utility application we call OTIO View that lets you look at the structure of a timeline. And so this is meant for developers who are debugging or learning how the system works. It's not really meant to be an end user tool, but it's really helpful for looking at the structure of a timeline. So here's a timeline, a segment from one of our recent films. And you can see that on the right side, we're showing the actual sort of contents of the OTIO file format itself. So it's meant to be fairly readable. Lots of words that you might expect are in there. And you can also see one of the key features of OTIO in here, which is the ability for us to attach arbitrary metadata to basically any object within an OTIO data structure. So here I've highlighted one of the clips, and you can see there's a dictionary of metadata with some custom Pixar production tracking information attached to this clip. So you can put your metadata here as well, and that can coexist with other people's metadata. So that's meant to be very extendable. And so using that sort of metadata capabilities to carry production tracking information, we can build flexible workflows with handoffs between different commercial applications, legacy formats, in-house tools, sort of whatever's necessary. So this round trip example shows a workflow that we have in use at Pixar, where we use AAF and EDL to interoperate between third-party tools, but pretty much everything else uses OpenTimelineIO. And the adapters allow us to bridge the gaps between those other formats. We'd love in the future to have the entire ecosystem use OTIO natively to do away with the adapters. And so we're hoping to do this in the future. So now let's talk about the things that we've done over the past year or so since our last update. One of the key things we did was we've added support for a bunch of different programming languages. So previously, OpenTimelineIO was implemented in pure Python. And this was great for getting the API up and running. It fits really well with a lot of the visual effects and animation studio pipelines. Python is great, we love Python, but it's not the right fit for everybody. And so we ported the core of OpenTimelineIO to C++, and then wrapped that back into Python. So you can get at the same functionality both ways. This was meant to be backwards compatible. So Python developers shouldn't really have noticed much difference. There was maybe a little bit here and there, but it should have been a pretty smooth transition. And then having the core in OTI and C++ lets applications and developers use OTIO without needing to include Python in their application. So in addition to the C++ API, we now have Swift bindings, as well as a C API and a Java API. And actually, two of those, the Java and C API, were done by through the Google Summer of Code project. So Karthik Iyer was selected as our Google Summer of Code intern. And Karthik's project is just wrapping up right now. And we're really happy with Karthik's work. He's been fantastic. And participating in the Google Summer of Code was a really great experience for all of us. And we thank the Academy Software Foundation for setting that up and supporting us in that way. And we look forward to working with Google Summer of Code again. Karthik is amazing, so thank you. So now that we have these different APIs, so applications written in any of those languages can use OpenTimelineIO much more easily. So for example, with the C++ API, we ported the core of OTIO, and that actually doesn't include the adapters. So the adapters are still in Python. But that means that your application can still read and write those other formats by running them through a utility that we provide called OTIO convert. So that still gives your application all those benefits without having to actually include all of that adapter code in your application. So at Pixar, we've actually integrated it exactly in this way. So our in-house animation system called Presto uses the C++ API directly to read and write OTIO, and we use OTIO convert to convert from AF, for example, and a bunch of other legacy proprietary formats that we've used over the years. So this has been a great way to sort of modernize our pipeline without dropping support for those old things. Next, another new feature that we've added in the last year is support for image sequences. And so if we go back to this diagram for a minute, we can see that this clip on the bottom track there has a media reference, which points to the actual media on disk via a URL. Excuse me. So lots of workflows involve sort of relinking from one piece of media to another, whether that's switching proxies or doing some sort of online, offline conform. And so new in this most recent release of OpenTimelineIO, we have support for image sequence references. So an image sequence reference points to a numbered sequence of image files, commonly in a folder on disk. And a lot of other systems will use like a very compact format for specifying how those zero padding and things like that work. The schema that we developed allows for a really clear specification of the naming conventions for those files. So we have a prefix, a suffix, a start frame, a frame step, and zero padding information. And so we believe that this will support all the common file naming conventions used in our industry. Doing the schema like this is in line with the design for many other parts of OTIO, where we're favoring readability and clarity over compactness. And adapters are free to convert to and from this and other syntax, like you might see in an application like Nuke or RV that are more compact. Also, I just want to highlight the work for this was done by Netflix and Storm Studios, and we really appreciate the collaboration in that. Next, look at some of the improvements we've done to the adapters. So we made a bunch of improvements to the AAF adapter, and this is mainly focused on reading and writing, interoperating with Avid Media Composer. We support more complex nesting and very mixed frame rates, and we got a lot of assistance and participation from Cargo Cult, as well as technical assistance from Avid. So we really appreciate that. We've come a long way. There's still more to add, obviously, but it works pretty well. We've also had lots of community contributions to the Final Cut XML support, the EDL improvements from Rodeo Effects, as well as improvements to the KDN Live and XGES support as well. Next, we wanted to highlight OTIO's integration with Autodesk RV application. So what we've done is we've built a plugin for Autodesk RV playback tool that supports reading and writing OTIO files directly in the RV interface. So RV supports Python plugins, and so using the OTIO Python API, we're able to read and write any format that OTIO supports. And so just as an example, here's an OTIO file that we have from our editorial department. It's got 2 tracks in it. The video track has dozens of clips in it, and the audio has a mix down of the sequence. So this just happens to be one of the ways that we work at Pixar. And so via this plugin within RV, you can select an OTIO file in the file open dialog, and you can actually support any format that OTIO supports in here as well. And you click open, and then RV then uses the OTIO API to read the timeline, and it builds an in-memory session with all of the linked media spliced together. So here we've loaded the same document that we looked at before, and you'll notice the timeline down at the bottom. You can see it has all those dozens of clips spliced together, and then if I were to press play, you would hear the audio for this, since we've recreated that composition in RV's node graph. So this example sort of plugin is included in the OpenTimeline repository, and this was a really nice collaboration between folks at Pixar some help from people at DreamWorks, and also technical support from Autodesk. So this is a really nice thing that we hope to add some more features to in the future, but it's good to see this coming together. And next, we'd like to invite some of the folks from the community to talk about how they're using OpenTimelineIO. And for logistical reasons, we've pre-recorded these segments. So we're going to start off with welcoming Daniel, who's also here for Q&A later, to talk about how he's working with OTIO in Hero and in Nuke Studio.
Hi, my name is Daniel Flehner Heen, and I'm a pipeline developer at Storm Studios in Oslo, Norway. And I've written a plugin for Hero and Nuke Studio that lets you import and export OpenTimelineIO files directly. Quick feature overview. You can import and export entire timelines with audio-video tracks. You can do constant speed up or down or reverse. You can do cross-dissolve and fades, tags, and you can append tracks to existing sequences to build timelines. Since nested sequences aren't supported in Hero, this is solved by leaving a gap in the original timeline and creating additional sequences. I preserve links between audio-video tracks for clips, and you can export a selection from the timeline if you like. You get this additional import action in your context menu, either in the bin view or in the sequence or timeline view. Here I've imported a sample timeline from the main repo. And when you export, you set up this new OTIO exporter content to get the OTIO files. Here's an example in OTIO view of the result. And the plugin was originally written as a part of our delivery tools. So at the bottom left here, we usually start with the delivery specs from the clients, which we then parse and turn into a bunch of JSON and Python files that describe the outputs. We then pass the VFX edit from Hero to our delivery tools via OTIO file, and the delivery tools make sure that we gather the correct source files and convert the naming convention to the clients, and set up a bunch of batch renders for the render farm, which then produce the movie or image files and updates the submission form, all based on the OTIO file. So we start in the timeline of Hero, update our edit. We add submission notes as tags to the clips, and we export the selected shots. Here we see it in OTIO view again, and we can use the tag information or the submission notes for the slate frame, for instance. And here we see that we use the note, which is more verbose in the slate frame, and we use the label or the subject as a burn-in. And we also pass the note to the submission form at the bottom there. When required by the client to create a minicut, or if we want one ourselves, we can export the entire timeline to get the offline audio, etc. And we then pass that to our custom MLT adapter, and that goes to Melt, which is Media Loving Toolkit's command line video editor, which produces a minicut for us on the farm. Yeah, so the plugin should be available through the main OpenTimelineIO repo. Please check it out, and thanks for your time.
All right, thanks, Daniel. That's really exciting to see. I'm glad to see both an example of integrations with third-party tools, as well as a nice studio workflow really coming together in a powerful way. So check out the code that they've contributed. All right, next I'd like to welcome Andrew Moore from the Cargo Cult to talk about how they're using OTIO in their new product called Matchbox.
Hi there, and greetings from Wellington, New Zealand. My name's Andrew Moore. I'm a sound editor and software developer based here in Wellington, and today I would like to share with you a brand new change management tool from the Cargo Cult. It's called Matchbox, and we've designed it from the ground up with support for the OpenTimelineIO platform. First, let me give you a brief rundown of where Matchbox has come from and why these kinds of tools have become such an invaluable part of our workflow here in Soundpost. As budgets decrease, post-production schedules shorten, and directors and editors become more accustomed to making changes right up to the last minute, a hugely important part of our job has become chasing the cut, or reconforming all of our sound editorial work to meet the latest version of the picture edit. For a long time, getting EDLs from the editorial department was our lifeline, providing a systematic way to track the changes that are being made. Out of this mess of shot names, version numbers, and timecode strings, Conformalizer was born, a dedicated tool for comparing EDLs and showing the differences, finding the bits that match, where they've shifted to, and where the new material is that you need to look at. You can then apply those changes to a Pro Tools timeline, patch the holes, smooth the edit points, and you're ready to continue on with your work. EDLs have been good, but they're not without their problems. As the complexity of an editor's timeline increases, say building comps, applying effects, or creating nested sequences, so does the complexity of generating an EDL that we can use for a broader top-down comparison. The better solution is just to work with what the editor works with. No stripping of information or flattening of tracks, just give us your multi-track timeline and let us do the rest. It'll save time, it'll save money, it'll get us a better result, and it'll help with communication between departments. So this brings us to 2019 and to the beginnings of creating the successor to Conformalizer 4, which by now is one of the most widely used reconforming tools in the Soundpost industry worldwide. And it's also where OpenTimeline becomes an integral part of the story. So why use OTIO? For us, the answer is obvious. This is all about timeline information. We don't care where the information has come from or how it was generated. We just want to see it. We want to compare it, and we want to try and make sense of what the differences are. Through OpenTimeline, not only do we have access to the native and third-party adapters, AAF and XML being the most prevalent for us, but also to all future developments that happen as this platform evolves and gets more widely adopted across the industry. One parser can open the door to many formats, and this then opens the door to anyone who wants to build custom workflows using OTIO and leveraging Matchbox's incredibly powerful comparison tools. So let's take a look at all of this in action and see just how powerful the combination of Matchbox and OTIO can be. Here we have the latest version of the cut handed over to us by the editorial department. A pretty standard collection of files, a QuickTime, some audio guide tracks, an EDL, and we also have an AAF file. So let's just go ahead and import this now. This AAF file here is simply a direct export of the editor's timeline as they're working on it in the cutting room. No pre-processing necessary, just select and export. Using OpenTimeline behind the scenes, we can simply drag and drop this file onto the Matchbox timeline, and we begin extracting all of the necessary information. There is now also an OTIO file on disk right next to the AAF, ready to be used for next time, or ready to be analysed with any other OTIO compatible tool. Now, let's grab the QuickTime and those audio guides, and let's also load the previous version of the cut, which is conveniently stored in one easy-to-access file right here. We simply call it a sequence file. Now that we have everything loaded to our new timeline on the bottom and our old timeline on the top, Let's just compare these two and see what the differences are. What Matchbox has done here is create a number of events that are a match between the old and new cuts. We can see where these sections have been moved, where new shots have been inserted, where old shots have been dropped, where sections have been reordered, and where shots have been updated for a VFX update. Very handy. If we switch to the diffs layer briefly, we can see here where Matchbox has found some things that we will be particularly interested in. Using the VFX tracing ability, it has found a clip here that has gone from version 6 to version 7, and will automatically do a comparison of the images and show us exactly what's changed. A helicopter has been added to the shot here, so we'd better make sure that the sound effects editor knows about this and adds one in for the next review. Now that we have all of this info here showing the matches between these two versions, what can we do with it? Well, we can run a reconform to update all of our material to this new version. We simply click on the Run Reconform button up here and get the process underway. Now, for us in the Soundpost world, we are reconforming a Pro Tools session, which happens in real time as Matchbox does all of the necessary editing for you. But what else can you do? You can reconform any text files, tab or comma separated, that has standard timecode strings in it, perfect for reconforming a database of dialogue or a list of specific VFX shots that you might be interested in. You can also reconform a closed captions file. But this isn't just about post-production sound. We can now programmatically reconform a hero timeline by selecting the Export Hero Reconform Data option here, and then using our specialized system inside Hero to update your timeline to the new cut. Keep all of the work you've already done getting your timeline set up, and just link to your new plates and get back to the job at hand. All of this data has obviously come out of a non-linear editing system, in this case Media Composer. But with OTIO, you have the ability to incorporate Matchbox's powerful comparison tools into your pipeline natively. As a very, very basic example, I have a simple script set up here to create an OTIO timeline. There's nothing fancy going on, we're just creating a few clips, adding them to our timeline, and creating an OTIO file. Now, let's just tweak things slightly. Here's one where we've got version 2 being generated right in front of us. After generating these files, which you can do using whatever data you have in your pipeline, we can simply drag and drop these directly into Matchbox and hit compare. We immediately see where the matches are and where the changes are. We can see there's been a new shot added here, and that this shot here has rolled a certain number of frames. This is just barely scratching the surface of what can be done using this powerful system, and we're very excited to see what kind of workflows people will start to create to streamline the process of comparison, of reconforming, of review, but most importantly getting the complicated work of tracking changes out of the way so we can all focus on creating beautiful sounding and looking films, episodic shows, commercials, games, just telling stories and entertaining people. So that's all for today. Thanks very much for checking out this quick demo of Matchbox and how we are utilizing OpenTimelineIO to help people work smarter, work faster, and have more time to focus on the creative stuff that matters.
Awesome. Thank you, Andrew. That was really fantastic. I'm especially excited to see this coming together with the flexibility of OTIO, all the different adapters, and having these sort of change management things available in our industry. We've been approached many times over the past few years about how do I compare two OTIO files and how can I do this sort of comparison stuff. So I'm really excited to check this out. Next, we're going to talk with Mike Mahoney from Pixar about the OpenTimelineIO web service that he's developed.
Hi everyone, my name is Mike Mahoney. I'm a software engineer in the production support engineering team here at Pixar. I wanted to show you today how we use OTIO via a web service. To start off, here's our place in the Pixar pipeline. We receive submissions from editorial, the domestic production version of the film, as well as any trailers, any of the 43 different localized versions of the film, and stereo versions of the film. They're submitted to a web application that the user then interacts with to vet and catalog and approve and store the submissions. They're then passed to color grading and packaging and shipping. So we started using OTIO back on Incredibles 2 in 2017 in order to do dissolves in a different way. Prior to the movie, dissolves were handled on the production side of things. They were turned into a D-shot, which was then passed to mastering for color grading. Incredibles 2 requested that we keep the shots separate, apply the grades in mastering, and then allow the mastering software to do the dissolve. So at the time, and for the previous 20-ish years, submissions were made to mastering in the form of a film log. That's just a playlist of shots, but no transition information. Serendipitously, the OpenTimelineIO project was just spinning up, and as you can see here in this sample OTIO file, there was the concept of transitions. Seemed like a great place to start. As we dug in, we started to find more useful aspects of the OTIO project that really sweetened the deal. The format conversion plugins provided in the base, as well as the idea of the contrib adapters and internal Pixar adapters, meant that we could support in our pipeline any of the various file formats that individual pieces of the pipeline might need along the way. So when editorial would submit to this cataloging web application, you can see here highlighted in yellow, we immediately saved the submission in its original file format to storage. And we found that a versatile way to incorporate OTIO into this application, as well as others, was as a web application that all playlists would pass through upon retrieval from storage. You can see here that now, by virtue of the adapters, we can support either in or out any of the file formats supported by the OpenTimelineIO community. Now, a quick but important aside, the CMX3600 EDL adapter at the time didn't actually support transitions, but after a bit of research figuring out exactly how transitions were represented in EDLs, the actual implementation inside the adapter to support writing transitions was super straightforward. So, as we pull the EDLs out of the system for color grading as requested by Incredibles 2 production, we can now satisfy that request. Along the way, we also began to realize that OTIO would help us with catalog remastering as new technology like HDR and 4K come along. Thanks to the upversioning built into the OpenTimelineIO base, any media that we pull out, whether it's legacy film logs, legacy OTIO versions, it's all taken care of, and we always get the latest and greatest when pulling from storage. So this primary application, as well as others we've written since and scripts, interact with OTIO via a microservice. You can see here it's deployed to our internal cloud at a production and a staging environment, as well as dev environments, and provides endpoints for listing adapters as well as any kind of conversion the adapters are configured for. You can see in the example usage here that we can take binary AAF as input, or EDLs, or logs, or URLs with authentication cookies, which is actually what we use most in this primary application to fetch playlists from an S3-like storage system. Here I'm using the HTTPy command line utility for listing all of the adapters that are currently registered with this host. Here's an example OTIO file that is actually pretty sparse. One thing that I love about the current OTIO implementation is that we can thin down to just the basics and it will still be parsable upon ingest. We can then pipe that into our web service and get it out as a up-versioned OTIO file. You can see here that media references are actually connected through the Pixar media linker. We can get it out as an EDL, for example. We can get out as an EDL that is in the Nucoda style. You can see here the two different styles deal with the from comment in different ways. We can get the media out as play format, for example, a Pixar Presto playlist format, or as a film log saved to disk via our utility here. Pretty easy. The microservice code itself is pretty small, only a couple hundred lines written in the Tornado framework with Python 2.7. Benefits of this micro web service architecture include independent continuous deployment to either a staging or production environment into multiple nodes. Since it's all transient, we can spin up as many nodes as we need, concurrent processing. Any external dependencies required by any of the adapters are contained to the nodes, don't need to be installed in every using software package. Any number of using services get to share the benefits of maintaining a single microservice deployment. And we've actually found that we can pass the endpoint off to our users, and they find it straightforward to prototype and play with in script. We find that the development workflow is also pretty straightforward. It involves three main players, Docker, GitLab, and OpenShift, which is actually a container orchestration platform built on top of Kubernetes. Our local development all happens within Docker containers. The OTIO package, as well as our Pixar adapters, are pip installed via requirements text file via our internal PXPy PI service. And we use a simple makefile to spin up our dev containers and run unit tests and end-to-end tests, which have proved handy as the OpenTimelineIO core package evolves. We use GitLab to build and run tests and perform reviews and deploy to our various environments with the push of a button. That's it. Thank you so much for watching. Feel free to send me a message if you have any questions.
All right, thanks, Mike. I'm really excited. This is to see OTIO used close to home, but also in a really flexible way that's made our pipeline run a lot smoother. So I appreciate that. Okay, next up, let's talk about our roadmap and sort of where the project is going in the future. And as part of that, we really want to highlight that there's been in the last year or so, there's been a really strong sort of uptick in community activity in the project. We're getting a lot of questions and ideas and code contributions from a lot of different folks. And we really appreciate this. This was one of the main reasons why we wanted to open source OpenTimelineIO and also to engage with the Academy of Software Foundation to really find our peers working on the same kind of stuff in lots of different companies, lots of different use cases, and be able to cooperate with each other, which is really great. So what we're trying to do is we're trying to shift to some more community leadership on specific projects, and to set up some more sort of working group meetings and help kind of facilitate people working on things. So the recent image sequence support project, I think, was a great example of that, where folks from a couple different companies were able to cooperate with each other and build an improvement to OTIO without our sort of sort of core team needing to do a lot of that work, and inviting new people into the project as well. So we have a bunch of sort of projects that are active in some form or another, some more so than others. There's been some improvements to our continuous integration build system. We're switching from Travis to GitHub Actions, for example, as well as improving our CMake system. The Google Summer of Code project that I mentioned earlier is wrapping up. There's an effort underway to more formally document a sort of specification for the OTIO file format and data model. There's a contribution from Autodesk that's specifying a spatial coordinate system schema. There's discussion about a prototype of an editing API. So with methods for doing the sort of overwrite, insert, and those kinds of things that were previously not, those operations were not really represented in OTIO. There's a Blender integration underway, and improvements to lens metadata. So these are all sort of going in some form or another. So if you want to participate in any of those, you're welcome to. There's also future projects, things that we've talked about that are not necessarily underway at the moment, but that we're hoping that folks from the community will step up and try to champion these things. So one of which is the nonlinear time warp effect. We've made some stabs at this in the past. somewhat unsuccessfully, but we'd love to move forward on that. That's something that comes up quite a lot. There's discussion about annotations, so drawovers and textual annotations. There's been requests for sort of time varying metadata, so something that might be sort of animated over the course of a clip or change over the course of a clip. We hope to do some improvements to the way we represent time. There's definitely some room for improvement in our documentation, and we'd like to support video effects in the future as well. And also just a shout out to, if you have an application that deals with timelines, please add OTIO support into your application. I think we're getting pretty far with the notion of adapters and plugins coming from the community, but we really like to see developers in this realm really adding native support. We'll help to answer your questions and figure things out. So please reach out to us if you need some help with that. So if you'd like to get involved, our website is available at OpenTimeline.io. We have a mailing list, which is mostly sort of announcements, but we're open to questions and discussion on there as well. There's a Slack channel, which has quite a few people in it now. That's where a lot of the discussion is going on. So you can join that there. And we also have every other week our steering committee meetings, which are open to everyone. And we've seen new people sort of showing up to that, getting lots of good discussion. And that's a great way to meet the people who are involved and to talk about things that you want to contribute to or influence in our roadmap. And with that, we'd like to open it up to questions. And we have a bunch of people from our community here who are available to answer things as well.
Hey, Josh. We have one in the Q&A list here from Simran. And he asks, will adapters be ported to C++ officially, or will this be up to the community, or is Python going to be the sole option?
Okay, that's a great question. I would say at the moment, we've gotten a few questions about that. At the moment, we don't really have plans to port those to C++. It's not really at the top of our list. I think that we're open to discussing that. There's nothing really preventing that. We were, I think, a little shy about introducing a plugin mechanism to the C++ infrastructure. There's a bunch of different ways of doing that. So if you have sort of thoughts on how that could work well, that'll be good to know. So it's not really high on our list, but if you want it, like that's part of this being a community-driven project. If that's something that the community wants, we're happy to help facilitate that.
Great, and we've got one other one here from him. If the OTIO format is extensible, would you recommend it as a native storage format for an NLE? Any pitfalls?
Yeah, that's a great question. I think that we originated OpenTimelineIO as an interchange format and an interchange sort of workflow thing, which is meant for the something you would find in the sort of import or export dialog in an application or files that you're handing off. But we have had quite a few people ask about using it more as like the native file format for something, or using OTIO as the sort of in-memory representation for something. I would say that if you were to go that route, you might be the first ones to do it. So it would be interesting to sort of find out how that goes. I think that we've certainly done some things in-house where we're using OTIO as like the primary file format for some of our workflows, and just putting a lot of interesting things into the metadata for it. And that's worked okay. It doesn't. Sometimes an application or a specific workflow will want, larger sort of binary things or other stuff like that in their native file format. So you may find some challenges there. yeah, I think that would be a great thing to sort of talk with us more on Slack and at our TSC meetings and kind of find out some more of like what you have in mind with that.
Great. Any other questions?
I think one question maybe we have for the community is, how did the transition from the pure Python to the C++ core work for people? Is it, hopefully that went pretty smoothly. I know we did hear from a couple of people who had some problems. So if there's anybody who's sort of still having problems crossing that transition, it would be good for us to know, because we don't want folks having to linger back on old versions of OTIO. And are there other things that you feel that we should have on our roadmap that you didn't see there, or things that you're particularly excited about? Feel free to chime in if there's something that you want to sort of upvote a bit.
Oh,
I see.
oh, go ahead.
Oh, yeah, I see a question about, will OTIO help unify editorial ingestion and interchange between various editorial packages like Avid, Premiere, Final Cut, and Hero? I think that going straight from one nonlinear editing application to another is something that OTIO could certainly help with. Several of those sort of already have some support for things like the Final Cut XML or AAF format. So that's something that we'd love to sort of see in the future. I think our emphasis has been getting things from nonlinear editing applications out to sort of the rest of a visual effects pipeline, for example. But there's nothing sort of stopping us there. I think that the developers of several of those applications have been maybe a little sort of cautious, or maybe supportive of us, but not really like jumping in head first, which is fine. I think that's something that, as long as the community is sort of asking for that from those folks, I think that could be really helpful. Yeah, hopefully I answered your question. The question: do we support time-based conversions between the NTSC non-integer rates and integer rates? We do have some API for working with some of those things. We don't really have something to say like conform your timeline from one of those rates to another, if that's your question. So there's sort of like low-level support for those rates. But I think it would be up to you to write something to actually define how you want to snap things from one to another. And that would be a great sort of use case, a great sort of workflow use case to get into. So yeah.
I was going to say, maybe to add some clarity to that also, OpenTimelineIO is frame rate agnostic. So, unlike some other formats that might specify that everything is in terms of a given edit rate, you're able to specify your time sort of in whatever way is native for the media, or if you wanted to specify everything as being snapped to a given edit rate, you could do that. But again, that's, as Josh was alluding to, that's an exercise for the user of OpenTimelineIO to decide when they want to, use things at a certain rate or express it in media native.
The next question is about the rough ETA for the documentation overhaul. And no, there isn't. One thing that we're discussing is, as a community-based project, it's a little hard for us to sort of put deadlines on a lot of things. I think we've tried that in a few cases around our release schedule, but at the moment there's no schedule for the documentation overhaul. If there's particular areas that you feel we should focus on first or whatever, that would be good to know. Let's see, is anybody attempting to use the C++ API directly in their native application? All right, well, perhaps we've used up all of everybody's questions. Maybe next time we'll do some prizes for people to ask questions. If you have other questions later, feel free to reach out to us on the Slack channel. Is probably our preferred way of just sort of Q&A. The mailing list works great as well. And that's all on the slide here. I believe that this the recording of this session will be available sometime soon. And we're really glad to talk with you all. And thanks to everybody who contributed to the presentation and everybody who's working on the project. It's been really, really great to meet new people and to make progress on this project together. So thank you, everybody.